Alright, let's have a look at some of the questions on the practice test. I'm just sort of going to go through them one after the other, just in separate videos. Right, so question one, we're talking about plants like mulberries. um, and we're interested in the female mulberry because they produce the fruit. So we've got some seeds. Seeds are equally likely to be male or female, so that means there's a probability of 0.5 that it's female, and each seed is independent. We're going to plant 4 seeds, and we want to know the probability of at least one female plant, and we want the probability. Oh, we want to know how many seeds would be required to ensure that there's a probability of at least one female plant greater than 99%, right? So we obviously increase the probability of seeing a female plant if we plant more seeds. So let's interpret this question. Let's put it into some sort of nice notation. Let F be a female plant, or a pistillate plant. Then we know PF equals 0.5. That's from the equally likely bit. Each seed's independent, and there's 4 planted, and we want at least one plant to be female. The complement of at least one plant is that they're all male. So we can answer this question by looking at the probability that we get female complement, female complement, female complement, female complement. Right? So they're independent. The probability of F complement is 0.5 as well. So the probability that we get all male plants is 0.5 times 0.5 times 0.5 times 0.5, right? And then we have that the probability of at least one female is 1 minus PFC. Oops. All right. So 0.25, 125, 0, 625, 1 minus 0.0625, I believe. All right. So that's our probability that we get at least one female plant if we're planting 4 seeds. Okay. This one's a bit trickier. The next one, how many seeds would be required to ensure the probability of at least one female plant was greater than 99%? Well, that's the same as asking that the probability of all male plants is less than 1%. So is 1 minus probability of n male plants So we know this probability has to be 0.99. 1 minus, this is just 0.5 to the power of n. right? We kind of saw that earlier in the question. So, oops. So this is what we've got. We've got the equation 0.01 equals 0.5 to the power of n, and we need to find n. So I'm just going to leave this as an exact form because I don't have a calculator on me. We take the logs to get the n down in an easily manipulated way. Oops, I need this. Sorry, this should be an inequality. Want it greater than 99%. So when we rearrange this expression by dividing by log of a half, we've got to remember that log half is less than 0, right? So we're dividing by a negative number. That means we're switching our inequalities. So we have to be quite careful with this. We find that n has to be greater than log of 0.1 divided by log of 0.5. And you can stick that into your calculator and obviously just round up to the nearest integer. And that means it's greater than this, so it's really like the ceiling of that fraction on the left. You're fucking kidding me. I didn't record this. Fuck.